Okay, guys. Today we are going to start simplifying some radical expressions. It's a really important skill that we learn in algebra that we apply in a lot of higher level math, geometry especially, next year. So being good at this is really important. It's really about number sense and knowing those perfect squares. If you remember, I made you memorize a list of perfect squares. And if you recognize those numbers and you remember those numbers, you're going to find this to be a little bit easier. Knowing those perfect squares is really a foundational skill that helps you with this. So let's talk about this. When a radical contains a number that is not a perfect square, like the square root of 50 or the square root of 72 or something like that, we've used a calculator to find that rounded decimal to estimate its value. We did that when we did the quadratic formula. We took those imperfect squares, we rounded them to the nearest tenths place or hundredths place, and estimated the values. But instead, you can actually sometimes, not all the time, but sometimes, you can simplify these radicals and keep your answer exact. It will not be estimated around it. When you do that, it's called simplest radical form. That's our vocab term, simplest radical form. So if it's possible, here's how we simplify them. It's not always possible. What we're going to do is we're going to look for factors of the number that's inside the radical. That number is called the radicand. It's the number inside the radical, which is not a perfect square. We're going to look for factors that might be perfect squares. So for example, we're going to look for factors like 4, 9, 16, 25, 36, 49, etc. That whole list of perfect square numbers. And when you factor that number inside, you break it down to factors, because it's not a perfect square, at least one of the factors will not be a perfect square. So we're not looking for like 10 as a factor or 5 as a factor or things like that. We're looking for a factor that's a perfect square. Okay? So we're going to find that factor that's a perfect square, and we're going to take that number inside the radicand, and we're going to break that number down into a set of factors. And then we're going to remove the perfect squares from that radical by taking their square roots, and that brings them outside the radical. And then the factors that is not a perfect square, that remains inside the radical. So your final answer on most of these, if not all of these, is going to have some number outside the radical that came out because it was a perfect square, and then some number left inside the radical that's not a perfect square. And really be careful, because to simplify it completely, the number that's left inside should contain no more perfect square factors. So sometimes that number inside the radical might have two different perfect square factors that you may not recognize both of them. So if you only bring out part of that perfect square, you're not fully simplifying it. You're only partially simplifying it. So it'd be like if you had a fraction that was 10/20ths, and you divided by 2 and made it 5/10ths. Well, that's not fully simplified. It's only partially simplified. So we want to fully simplify this. So let's take a look and see how it works. I got 6 examples for you. So here we go. We're going to simplify the square root of 8. Well, the square root of 8 is not a perfect square. But if I think of factors of 8 that are perfect squares, well, 4 is a factor of 8 that's a perfect square. So I'm going to break this down now. So this is not the square root of 8 anymore. It's the square root of 8 broken into 4 times 2. Okay? 4 is a perfect square. 2 is not. 2 is going to remain inside the radical. The 4 is going to come out of the radical by taking its square root. So the square root of 4 is 2. So the 2 comes outside, and then the square root of 2 remains inside. And that is my simplest radical form answer. Be really careful with this 2 out front. Make sure it's not inside the radical. Then it's a little square root or a cube root or whatever number goes in there. Also understand what this number outside the radical does. The radical is a grouping symbol, just like parentheses or absolute value or brackets. We've had a lot of different grouping symbols. So a number outside the radical multiplies that. So if you want to mentally just know there's a multiplication symbol there, it's going to come up later. So the answer is 2 times radical 2, or you could just call that 2 radical 2. How about the square root of 75? Well, you may not see it right away, what the perfect square factor is. You might think, well, 75 can be divided by 5. If I divide it by 5, that gives me 5 times 15. Well, 5 times 15 doesn't do any good because neither of these numbers are perfect squares. So I need to come up with numbers that are perfect squares to go inside this radical so I can remove them. So don't look for numbers that aren't perfect squares necessarily unless you have to. We'll talk about that in a minute. But I know that 75 has a perfect square factor, and that perfect square factor is 25. So 75 is 25 times 3. 25 is my perfect square. 3 is not a perfect square. 3 is going to remain inside the radical. The 25 comes out, and the square root of 25 is 5. And left inside the radical is the imperfect square, 3. So your final answer, simplified in simplest radical form, is 5 times radical 3, or just 5 radical 3. Not all quite that easy. 40 is not too bad. Some people are going to look at that and say, well, I can divide it by 2. But 2 is not a perfect square. It doesn't help me. I need a factor of 40 that's a perfect square. And that would be 4. All right, so 4 times 10. And you look at 10 and you say, well, can I break that down too? But 10's factors are 2 and 5. And neither of those are perfect squares. So even though 10's a nice looking number, it seems like you should be able to do something with it. 10 is going to be what's left inside the radical because there are no perfect square factors of 10. But 4 has that perfect square, and that's 2. So my answer is 2 radical 10. Again, 10 is one of those numbers where you look at it inside the radical, you're like, I should be able to do something more to that. And you can't. 2 times 5, neither of those factors are perfect squares, and it's as simple as it gets. Here's one of those ones that you might not know much about. 294. Oh, that's an uncomfortable number. Not many people know much about 294. So if you start trying to factor it a little bit, well, does 4 go into it evenly? 4 goes into 29 7 times. That leaves me 14, and 4 will go into 14 evenly. So 4 is not a perfect square factor. So I'm trying to find perfect square factors, and I don't really know any. 25, obviously not, because this is an even number. 9, well, let's see, 9 goes into 29 3 times, that's 27. Leaves 24 left over, doesn't go in evenly. So it's one of those cases where maybe to break this down, you need to come up with a number that's not a perfect square and divide that out. Well, I happen to do this ahead of time. I know this number. 6. 6 is a factor of 294. And 6 goes into 29 4 times. And that leaves 5 left over. And 6 goes into 54 9 times. And check that out. 49, that's my perfect square. So 6 was just a number I used to get my perfect square. You might have to work with that a little bit. Play around with the numbers and see what you can come up with. Because you're probably not going to start dividing this by 49. That's not necessarily going to help you. You're not going to guess that. Maybe you are, but more than likely not. So the 6 is going to remain inside, and this 49 is going to come out. When the 49 comes out, the square root of 49 is 7. And left inside the radical is 6. One of those common mistakes is when you take the number out of the radical, especially if it's a smaller number like 4, not so much a 49, you forget to take the square root. Don't forget when you take this number out of the radical, that's the perfect square, don't forget to take its square root. That's a really common mistake, to forget to take its square root and bring the number out as it is. So be careful with that. That's a little more complex, but really not much. Here's a number already outside the radical. Remember, that number outside the radical multiplies the radical. So I'm going to put a little multiplication symbol there just to remind myself of that. Let's break this guy down first. 18 is not a perfect square, but it has some perfect square factors. And the perfect square factor of 18 is 9. 18 is 9 times 2. And there's a 9 outside times that. So this 9 is going to be removed from the radical because it's a perfect square. And the square root of 9 is 3. So outside the radical, I have a 9 that was already there times, I'm bringing out a 3, times, left inside the radical is that imperfect square, square root of 2. Now simplify this. 9 times 3, well, that's 27. 27 times the square root of 2, or 27 square root of 2, or 27 radical 2, you could say, is my final answer in simplest radical form. So any number that you bring out of the radical by taking the square root will multiply any existing coefficient numbers that are outside the radical. All right, last one. 7 times the square root of 242. Well, you may not know many factors of 242, especially not ones that are perfect squares, but this is another case where maybe dividing by a number is not a perfect square will help you. Again, I did this in my head ahead of time, so I kind of know the answer, but if I divide this by 2, 2 goes into 242 121 times. If you were to divide by 2 and didn't get a perfect square, well, 2 is not going to help you, so don't use it. Use something else. In this case, it did. 121 is a perfect square. I'm going to bring that outside the radical. So I had a 7 out there. The 121 square root that comes out is 11. And there's a radical 2 left inside. And then multiply that coefficient times my square that came out. 7 times 11 is 77. 77 times the square root of 2, or 77 square roots of 2, or 77 radical 2 is my final answer. And that is how we simplify radicals.